Hello, and welcome to the first practice quiz of the year on the first two lessons, 1.1, 1.2. So this is on function notation, parent functions. This is just a quick practice quiz. It's very similar to the real one. I like to be intentional and let you know exactly what types of items you're going to be assessed on, right? So you know what to study, you know what to, focus on and prepare for assessments. So first one here says, give the name and or equation of the parent function that describes each graph. So this type of question, you just kind of have to know the parent functions, right? All 9 of them, right? Linear, absolute value, quadratic, square root, cubic, exponential, logarithmic, and rational, right? Look at that, all of them are in a row. You got to know these functions because it's kind of the baseline for what we're doing throughout the year. In each unit, we kind of dive deep into every function. But now we're just kind of getting familiar with what they look like, okay? So first one here, right here. You'll notice that is the cube root function. So I say cube root function right there. And notice it says give the name and or equation. I will give you full credit depending either way. If you write cube root, then full credit. Or if you write y equals cube root x, that works too. All right? Beautiful. I move to the next one. I see that iconic V shape. Beautiful, lovely. I say, hey, that's absolute value. Okay? Beautiful. Say absolutely. All right. So absolute value, that's y equals absolute value x, right? Okay. And then the next one, another icon right here is the rational parent function. You can see with these 2 asymptotes, right? It's the only parent function we have in Algebra 2 with 2 asymptotes, both vertical and horizontal. So I say this is the rational parent function. While I'm writing this, I will say try to commit to memory their domain and range as well. Now that's so much, you don't have to memorize that so much because as long as you know what the graph looks like and you can remember the shape of the graph, you can always figure out the domain and range, right? Okay, next one is the square root curve. That's what that one is. Square root curve. So you remember how it ends right here? It's because we can't take the square root of a negative number and get a real output. We will, however, talk about non-real outputs. Okay, moving on. Number 25. It's an expression is given below in either set notation or interval notation. So I'm just kind of assessing, do you guys know the difference, right? Inclusive, non-inclusive, kind of going from inequality to set, or inequality to interval versus interval to inequality, and just being able to fluidly see those as the same thing, yeah? So this first one says x such that x is greater than 6, right? Remember, bracket or these curly braces means that's a set. I say the name of the variable such that here's the condition on the variable. So I can draw a number line if that helps you. You don't have to. You're going to get to a point where you can just do this in your head. But if you like a number line, here's the number 6. And we say x is greater than 6, but not equal to 6. So I put a little hole here to show that it's not including 6. But greater than 6, well, numbers that are greater than 6 are to the right of 6, right? You can say, oh, that's 7, right? 8, 9, 10, and so forth, yeah? So that's my interval. And so if you're looking at interval notation, remember, it's lower bound, comma, lower, comma, upper, right? I'm not going to write it, actually. But anyway, it's lower bound and then the upper bound. You'll see that 6 is the lower bound, right? It's right here because there's nothing past 6 on that direction. 6 is not included, so we use a parenthesis. And it goes, what's the upper bound? Well, there is no upper bound. It's called unbounded because it goes forever and ever and ever to infinity. So let's say it just goes on and on and on to infinity like that. Okay? All right, next one. We have an interval from -10 to +10. So if you want, again, you can write a number line, right? What's this look like? Well, here's 10. negative 10 inclusive. Here's positive 10 not inclusive, like this. And the interval spans between these two. So it's really just everything in between, right? Remember, the interval notation, it gives you the upper and lower bound and implies everything in between those bounds. So I can see that my x values lie in between 10 and negative 10. So it kind of looks like that, right? Let me just draw that a little bit nicer. There we go. Subset notation, right? I do a little curly bracket. I say x such that negative 10 is less than or equal to x is less than 10. Less than 10. Beautiful. Next one, you see it is the entire number line. If you see negative infinity to positive infinity, right? There's negative infinity. That's on and on and on and on forever. And I keep on going to the right. That's positive infinity. That's all real numbers. But instead of writing ARN, like you might have in Algebra 1, we would like you to write it in an official set notation. We say, okay, it's the values of x such that x is a real number. And so the way we can write that is x is in the set of real numbers. And I close that set right there. All right? That's all that says. It says the set of x such that x is in the real set of numbers. Okay? All real numbers. Okay, last one. It says x such that x is not equal to 2. See this not equal, right? So think about your number line here. Whoa, what is that? Okay, sorry, I'm just being goofy. New boot goofing. So I put negative 2 here. It is not equal to negative 2. So that means not including that value. There's no other condition on x. So when we say x is not equal to negative 2, it implies it could be equal to everything else but negative 2. So that means we shade to the right of negative 2 and to the left of negative 2. Yeah? And so what's our interval here, right? Well, out that way is negative infinity. Out this way is positive infinity. And you kind of have to consider this as two separate intervals. The first interval is from negative infinity up to negative 2, parenthesis, because it's not including. The other interval is negative 2 to positive infinity, because that's on the right-hand side. And we join those intervals with the union operator, yeah? The union symbol, U. Beautiful. Let's move on. Number 3, write the domain and range for the relation in the graph below. Express your answer in interval notation. So we want to give the domain and range. So I'm going to use some various colors for this. So pay attention to the x-axis. See, domain is x. So we find the leftmost value. Well, the leftmost value is about right here. I also just noticed something, that point is not what I wanted it to be when I made this practice quiz. That's, alas, that is okay. Whatever, we'll deal with it. So, starts right there at negative 3. And you see, we're going to go, we're going to go, we're going to go. We're following along the line. And then we hit, oh no, a hole. And that hole or discontinuity happens at 0. And then we're going to skip over that hole. And then we're just going to keep on going. Keep on trucking. Doop-de-doop-de-doo, doop-de-doop-de-doo. And then we hit 6, right? Because it stops right here. That's the furthest point to the right. So I have 2 intervals here, right? This is 6. The first interval is from negative 3 to 0. You say, wait, hold on a second, Mr. Spade. Was negative 3 included or not included? And I say negative 3 was included. So it's a bracket. But 0 is a hole, right? There is a discontinuity at x equals 0. So we do not include that 0. We use a parenthesis. Now, the other interval, we start at 0, not including, and go all the way to 6. And 6 is included, as you can see by this filled-in circle right there. And again, just like that last problem, we connect these with a union operator. Okay. Now for the last one. I'm going to switch colors here. So blue. So for the range, we want to find where's the smallest, right? Where's the lower bound and where's the upper bound, and just pay attention to any discontinuities. So I see that the lowest value is about right here. And I'm just going to estimate, right? I'm going to say that's approximately negative 6.5. I meant it to be like a whole number, okay? I'm sorry. I wanted it to be on a, like right here maybe. But I guess that was an oversight on Mr. Spake's part. So call that negative 6.5, which we include. Negative 6.5 is my lower bound. And it's just going to go on and on, up. So I'm going to do, up and up and up, up and up and up. We'll go right through this little hole, and boom, right here. And this point is at 1. All right. Notice there were no discontinuities in this region. It just ended right there at 1. So it goes from negative 6.5 up to 1, but does not include 1. And that's it. That's the range. Okay. Don't worry. On the actual quiz, it is very clear what the points are. Sorry, that was just a mistake on this. Okay, last one. Here we go. And this is a classic. I say, what is the y-intercept of the function f of x equals blah, 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 blah. It's a quadratic function. Now remember, to find a y-intercept, this works for anything. Guys, you can take this to pre-cal. You can take this to calculus, all right? The y-intercept of any function, plug in x equals 0. That's it. That's the answer. That's how you do that, all right? You want to know that because, man, oh, man, that is a common question, right? We love y-intercepts. Those can be very helpful in things, okay? So I'm going to plug in x equals 0. Sorry, I didn't like the spacing. Okay, so what is f of 0? F of 0. I just substitute 0 for x. So it just becomes order of operations. I say 1 plus 1/4, 0 plus 6 squared. Of course, 0 plus 6, we know what that is. That's just 6 squared. Remember PEMDAS, right? I'm going to do exponents first, so 6 will get squared. 1 plus 1/4 times 36, because that's 6 squared. And then 36 divided by 4 is the same as 1/4 times 36, which is 9. And then 1 plus 9 is 10. And I have that lovely, lovely 10 right there. Please, 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 this is a note to the reader. Show this work. Show this work for full credit. Please avoid mental math, okay? I'm going to make this point in class, but you know what? Gosh darn it, I'm going to make it in the video too. Your work is not just for you, it's for the reader. That could be me, that could be a different grader, whatever. You have to, when you take a math class, you need to operate under the assumption that when you write something to prove some statement, right, you need to back it with justification. You can't just, if you just put 10 and box that, and you show me none of this, that's not good, okay? I know that for some of us, right, we can plug it, we could do it in our head, right? 0 plus 6 squared, blah, 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 blah. But please, please, please show your work, okay? Because, what if you make a mistake? I don't know. What if you square 6 wrong and you said it was like 12, right? And so you said, oh, well, it's 12 times 1/4 is 3, and then 3 plus 1 is 4. If you put 4 as an answer here, well, guess who's not getting those 25 points at all, right? If you show your work and then a tiny mistake appears, if you said that was 12, I'd probably give you 20 out of 25. I might even be tempted to do 22 out of 25, all right? Because that's such a small error. I can give you lots and lots of partial credit when you show your work, but if you just do mental math, that is very hard to do, okay? So please, please, please show that work. Anyway, hope you enjoyed this guide. I hope it was helpful, and Take care. Have a good one. Have a good night. Rest well. Make sure you had dinner. I don't know.